Let us solve some more problems on convergence of infinite series. Now, the series that we are given is 1 by root n times tan of 1 by n. So, the nth term u sub n is equal to 1 by root n times tan of 1 by n. Now, we take the limit as n goes to infinity of u sub n, which is equal to limit as n goes to infinity of 1 by root n times tan of 1 by n, and this goes to 0. That is, it is equal to 0. So necessary condition is satisfied. Since tan is a transcendental function, we go for comparison test. Now, since 1 by n times root n is equal to 1 by n to the power of 3 by 2, let b sub n be equal to 1 by n to the power of 3 by 2. Now, this is going to be convergent because p is greater than 1. So now we take the ratio u sub n by v sub n, which is equal to 1 by root n times tan of 1 by n divided by 1 by n to the power of 3 by 2. Taking the reciprocal, we get n to the power of 3 by 2 divided by n to the power of 1 by 2 times tan of 1 by n. Taking the square root of n above, we get n to the power of 3 by 2 minus 1 by 2 times tan 1 by n. So 3 by 2 minus 1 by 2 is 2 by 2, which is 1. So we have u sub n by v sub n is equal to n times tan of 1 by n. Now we take the limit. So limit as n goes to infinity of u sub n by v sub n is equal to limit as n goes to infinity of tan of 1 by n divided by 1 by n. Since as n goes to infinity, 1 by n goes to 0. So that means limit as n goes to infinity of tan of 1 by n divided by 1 by n is equal to 1, which is in the interval 0 to infinity, a finite value. So that means since v sub n is convergent, u sub n series is also convergent. Let us look at the next one. The series is 1 plus 2 factorial by 2 square plus 3 factorial by 3 cube and so on. So let's see whether it converges or diverges. So our nth term u sub n is equal to n factorial by n to the power of n. Now u sub n plus 1, that is the next term to u sub n, is equal to n plus 1 factorial by n plus 1 to the power of n plus 1. U sub n plus 1 by u sub n, the ratio, is equal to n plus 1 factorial by n plus 1 to the power of n plus 1 divided by n factorial by n to the power of n. So now we start simplifying it. So here n plus 1 factorial can be written as n plus 1 times n factorial. Yes. And in the denominator, n plus 1 to the power of n plus 1 can be written as n plus 1 to the power of n times n plus 1. So now this term we are taking the reciprocal to convert it to multiplication. So n factorial cancel out. What else goes off? N plus 1 cancel out. And we are left with n to the power of n divided by n plus 1 to the power of n. In the denominator, we take out n to the power of n. So we have n to the power of n divided by n to the power of n times 1 plus 1 by n to the power of n. Now n to the power of n to the power of n cancel out, so that we have a ratio u sub n plus 1 by u sub n is equal to 1 by 1 plus 1 by n to the power of n. So now we take the limit. So limit as n goes to infinity of u sub n plus 1 by u sub n is equal to limit as n goes to infinity of 1 by 1 plus 1 by n to the power of n. Now do you remember this? limit as n goes to infinity of 1 plus 1 by n to the power of n is the definition of E. So we have the limit equal to 1 by E. Now 1 by E is less than 1. So by ratio test, the series U sub n is convergent because it is less than 1. The next one, series U sub n is equal to series 2 to the power of n minus 1 divided by 3 to the power of n plus 1. So the nth term U sub n is equal to 2 to the power of n minus 1 by 3 to the power of n plus 1. Now we take the limit as n goes to infinity of U sub n, and this goes to 0. So which means the necessary condition is satisfied. Now, since exponential terms 2 to the power of n and 3 to the power of n dominate, ratio test is preferable. So U sub n plus 1 is equal to 2 to the power of n plus 1 minus 1 divided by 3 to the power of n plus 1 plus 1, which on simplification becomes 2 to the power of n divided by 3 to the power of n plus 1 plus 1. So now let's take the ratio U sub n plus 1 by U sub n equal to 2 to the power of n by 3 to the power of n plus 1 plus 1 divided by 2 to the power of n minus 1 by 3 to the power of n plus 1. Now let's convert this into multiplication by taking the reciprocal. And now let's simplify. 2 to the power of n minus 1, if it goes up, it becomes 2 to the power of n minus 1. So we have n minus n gets cancelled. So we have 2 times 3 to the power of n plus 1 divided by 3 to the power of n plus 1 plus 1. Here 3 to the power of n we take out, and in the denominator 3 to the power of n we take it out. So what do we have? We end up with 2 times 3 to the power of n times 1 plus 1 by 3 to the power of n divided by 3 to the power of n times 3 plus 1 by 3 to the power of n. Okay, now when we simplify this, 3 to the power of n, 3 to the power of n cancel out, and we are left with 2 times 1 plus 1 by 3 to the power of n divided by 3 plus 1 by 3 to the power of n. And now we take the limit. So when we take the limit, what happens? 1 by 3 to the power of n goes to 0. So we have 2 times 1 by 3, and that is less than 1. So which means that the series is convergent. That was convergence of infinite series. So if you found this session helpful, please do like, share, and subscribe. Comment suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.